So I would say let's start with the dbk+4.
Yeah.
What would you like to tell about that?
The dbk+4 consists of the receiver and the transmitter. We have installed both with a standard mounting distance of 40 millimeters. The transmitter is below, is connected via the 2-pin wire to the receiver. The complete electronic is inside here, and we have a 7-wire cable to the PLC.
And what do we have to know about the pin assignment?
We have 7 wires, 2 wires for the power supply, then 2 switched output, double sheet output, missing sheet output, and we have 3 control input lines, C1 to C3. With these 3 input lines, you can select the paper weight. So default setting is standard. It covers the 80%. You can select thin mode, and you can select a thick mode. And if you want to use the trigger mode, you choose one of the input lines to give a trigger signal to the DBK.
And what is this box for?
This box is here only just for demonstration. We have here 3 dip switches to give high level on the input C1 to C3, and we can see with LED indicator the state of the switched outputs.
So Johannes, I have 2 thin papers here. Can you describe us how the double sheet and single sheet system would work?
That's very easy to describe. You see the red light flashing?
Yep.
This means missing sheet.
Okay.
There is no sheet in between the barrier. If I take a single sheet, it changes to green light. Green light means single sheet. If I take 2 of this, I have a double sheet.
Okay. And there's no problem if we are above here or underneath?
That's a good question. We recommend to have a blind zone of 7 millimeters above the transmitter and 7 millimeters also under the receiver. So recommend in this area the paper not to be too close to the transmitter, not to be too close to the receiver.
Mm-hmm. I have here 2 other plates, let's say plastic plates.
These are plastic plates, roughly 0.8 millimeter thick. And again, we have the signal indicator for missing sheet. I put 1 sheet inside the barrier. We get the green light that indicates single sheet. I take 2-1, double sheet.
Okay.
And you remember I said you need a thin layer of air in between. It is not glued to each other, and therefore we can detect the double sheet.
Okay. So what about metal?
We are able to detect also thin metal, like this brass sheets here, it's very thin. This will work already in the perpendicular orientation, single sheet, and again, double sheet.
Okay, but
and you see, no teach-in required. It is a plug-and-play solution.
Okay. As I asked you now, would this also work with thicker material, thicker metal plates? Let's say 10 millimeters?
No. The machine builder calls very thick metal plates, 20 millimeter, 10 millimeter, also as sheet. For me, it is heavy metal. But when we speak about metal sheets, we mean some 10th millimeter thickness. Aluminium plates, you can control up to 2-3 millimeters. We can also control wafer, for instance.
And what about transparent material?
Transparent material, it is based on ultrasonic. We are absolute color independent, and therefore we can also control clear film. You see again the green light for the single sheet, and 2 sheets stacked up, a clear double sheet indication.
So now we have the opportunity to visualize our measurement.
That's right. I've already started the LinkControl software, and here on the screen you'll see the measurement writer. And if you have now a sheet of paper for me, here you can see in real time what the sensor is measuring. Yeah, and you see also that paper can give a very inhomogeneous signal, like here.
Yeah.
And if I put now 2 sheets of paper together, you see the difference between single sheet and double sheet. Double sheet is nearly nothing.
Okay.
It's in the noise.
Yeah.
And the opposite is missing sheet. You see it's like a line.
Okay, well, that works with thinner paper, but what about thicker papers?
If you have thicker papers, and this is not just only a thicker paper, this is a corrugate paper. You see here the wave of the corrugate paper inside. Have a look, I don't know. You see also in standard mode, the signal is extremely low. So now I show you a trick. If you have a too low signal, if you work with an inclination, you get higher signals. Let's have a look, not with this paper. Yeah. So this is an example where we have to switch to thick mode.
Okay.
That I can do here in that way that I start with thick mode. So thick mode starts now. Now we emit higher sound impulse and the sensitivity is higher. And as you can see, the signal is already higher.
Yeah.
And it is still a very small signal, but we are able to detect this. You see the green LED indicator is on green. That means we detect a single sheet. Now I take 2-1. And then you have again on the measurement writer a line, means I see nothing. And the LED indicator shows us double sheet. So this is very interesting. We have some specific materials where it can make sense to inclinate also the dbk+4. This is, for instance, for thick plastic materials. You know your insurance card or credit card. These are thicker plastic materials. Here we recommend an inclination of 27 degrees.
Okay.
If you control silicium wafer, we recommend 11 degrees. And here for paper or corrugated paper, we recommend an angle as high as possible to get a stronger signal here. Here you see double sheet, single sheet. In perpendicular, it could be that we get wrong signals, therefore an inclination can help in this case.
Okay. Well, this kind of sensor reminds me of a daily problem we all have when we have a paper jam in our printer. Would it be a help to use something like that?
Yeah, it would also help me when you buy a double sheet detector to build in your inkjet printer at home.
Yeah.
But this is a typical application on a sheet fed printing press to avoid that you have get two sheets into the printing process. It's the same what you know from your printer at home.
Okay.
Yeah.
So in which application do you use mainly the dbk+4?
It was initially developed for sheet-fed printing presses, but today we use it in a lot of different applications. In the so-called post-press applications for folding machines, where boxes are folded, in laminating machines, and we use it also in the food industry. I have an interesting example for you here. This is here an endless tubular bag with spicy inside here. And you see this is a bag with a spicy inside, and we have here areas where the bag is glued.
Yep.
And we use a double sheet detector to detect this area to cut the bags here. And the bag with the contents inside is detected as a double sheet, and this glued area is detected as a single sheet. And whenever the sensor detects a single sheet, the knife can cut the bag.
Okay.
So we use the inverse logic. We go on single sheet signal.
Okay.
Yeah.
Good to me. And do we have different housings and mounting possibilities?
Yeah, this is a standard housing with in M18 thread. We have the receiver also with a 19 degrees angled head. We have also, when you have reduced space to install the dbk, we have a version with M12 sensor heads that you can also see on the ESP4, and external receiver that you have one thread pipe with only the electronic, and you have an extra transmitter and an extra receiver.
What are the benefits of the double sheet control?
Reliable detection of double sheets, of course. Out of the box solution, no teach-in required. And you can install it perpendicular to the material. And we have 3 paperweight working modes, the standard mode that covers already 80%. And for extra thick material, you have the thick mode. And for very thin paper, you can select the thin mode.